Hello kids, today I will be giving the solution for uh, grade 6 science workbook, which is the Cambridge Lower Secondary, right? Now this is unit 2, which discusses the material and their structures, right? So we're going to go straight into this. Now exercise 2.1 is about sorting solids, liquids and gases. This exercise will help you to check that you understand the properties of solid, liquid and gases. Zara makes a cake with icing for her family, right? Now, while she's making the cake, these are the articles that you are supposed to consider, right? Flour, milk, we have beaten eggs, we've got sugar, right? We've got butter, we've got water, we've got food coloring, right? Now, these are the six, seven, eight, I guess, yeah, total of eight articles that you have to arrange, right? Now, write the name of each items are needs in correct column, right? So the solids, you have to separate the solids and the liquids, right? And later in that question, it is suggesting that here are some more items that add their names to the table above. You need to add a column to the table for the gas, right? And it's telling you how to make this, right? So I made this column, right, for the gases, and out of these, now these ones, right, they did not mark these, so I'm just gonna write the names over here, right? Some of the things are missing, misprinted, right? So let's call this as air, and let's go with football, right? I know which ones the articles are supposed to be there in this picture, but I just took two of my own and then I arranged them, right? So these are the now new arranged articles from this menu below, right? So arrange them in the columns, and this is all that is required by this question, right? Now, just to give you a clarity which one's which, right? I'm pretty sure you guys understand like flame is a gas, right? That's the only confusing uh, thing that is there. I think rest of them are easily understandable. Now do not go for butane gas. It is referring to burner, which is a solid material, right? The gas comes out of this burner that we use for burning, okay? Okay, now solid, liquids and gas. Now over here in this exercise, you will practice using interpreting information from a table, right? Arun has asked to test 5 materials to see if they are solid, liquid, or gas. He has carried out some of the simple tests on materials. He has not yet completed his results, right? So this is his result table. Okay, now I remember all of you just crazily filling all these things, but I've just left them empty because what I think is that if you look at the questions, you don't really need to fill this up, right? It's just asking plain questions, right? So solid material A is a solid, liquid, or a gas, right? Explain your answer. Now, if you look at A, right, I'm going to take the green pen, sorry, the black pen. Right, if you look at the A, it can be compressed, right? So since it can be compressed, it cannot be a liquid or a solid, right? Because only gases can be compressed. Okay, solid B, sorry, material B is a solid, liquid, or gas. If you look at B, it flows, but it has the same volume. That means it is referring to a liquid and not to a gas. Okay, because it can flow, liquids can flow, but they cannot be compressed. Right? C is either a liquid or a gas. Right? One test that could be carried out to identify which one it is. Right? Now in C, the information is not enough. So what other test can he carry out? He saw that it can flow, so he can compress it down and see. He can do this test and see whether it's a solid or sorry, it's a liquid or a gas. If it compresses, it's a gas. If it does not, then it's a liquid. Now D is a liquid. Is he correct? Right? Now if you look at D, it does flow, but it has fixed volume, right? So that means it is a liquid, right? Okay. E is not a gas. Explain how, right? Now he says E is not a gas. It's because the volume remains the same, and for gases they can be compressed, so their volume can be changed, right? What test would he do to decide if E is a solid or a liquid? He can again do the compression test and see, because the liquids cannot be compressed. Gases, sorry, no, not the compression, but he's gonna see the flow test. Sorry, my bad, right? He's gonna do the flow test to see whether it's a solid or a liquid, because liquids flow, solids don't flow, right? Okay, you can check on these answers. I've written them in advance for you people so that you guys can read easily, because I receive some complaints that my writing is a bit unreadable. But the idea is to just explain how these are happening, not to give you the answers, right? The answer they're just for the reference. right? These are to the point answers, right? Very strictly speaking, these are very limited answers, right? Just to give you the idea of what is happening, right? Now in 2.1c, the properties of solid, liquid, and gases, right? In this exercise, you will consider observing some unusual behavior of solids, right? In A, he's able to pour that solid down, right? It's flowing, right? In B, he found out that it is taking shape of any vessel that he's putting this powder in. And third, once he taps it down, he sees that the volume is also able to be reduced, right? You can see that it is now occupying lesser space. So which states of matter would you expect to property since it is flowing? That is with liquids or gas, right? A state or states, right? It should be gas as well over here, right? For B, it can take the shape of the container. That is, usually found in liquids. Gases actually also do the same, but since it's an open container, so only liquids would do this. Gases would need to be contained, right? And for the property C, which is compression, that is only depicted by gases, right? So solids are not to be discussed over here. Explain why floor has a property as shown in A. Because it is a powder, so it has small spaces. So these small particles, they can move over each other, appears to flow like a liquid, right? Now for B, they're taking the shape because these are particles which can freely move, right? These are solid particles in powdered form, so they can move around, so they can also appear to take the shape of the container. Same is with the third, because when you convert a solid into powder, there are huge spaces between the particles, and hence they can be compressed, right? Now these are the three answers that are there, right? You can easily pause the video to read over these answers as well, right? I'm just gonna swiftly go through this because it's a very long exercise, right? Okay. Now exercise 2.2, Marcus water heating investigation, right? So he first measures the temperature of the water in a beaker, right? He's got the beaker. Then he heats the water. He measures temperature every minute. He does this for 10 minutes, right? Okay. What safety precaution is Marcus taking? Number one, he's wearing these goggles, right? He's wearing the safety goggles, right? Number one. Number two, he's keeping away himself, right, from the hot objects, right? Now below, draw the table for Marcus to record his results, right? What table would he draw to mark his results, right? So since he's taking observations, so I'm going to put serial number, right? Serial number in there. Then I'm going to put the time because he's measuring time, and then I'm going to put temperature, right? Temperature is going to be degree Celsius, time is going to be in, let's say how many, he's taking minutes, right? So MIN, minutes. So I'm just going to take this, right? There's three columns. These are the readings for temperature, right? So over here, you can read that this is 54, right? Over here, this is 22. Over here, this is 46. Then we have at 2 minute, this is at 38, right? And after 5 minutes, this is at 62. And after 1 minute, it is at 30. So you just record it from 0, 1, 2, 3, 4, and 5, right? Because even at 0 there was a reading, right? This is 0 minute, right? So 1, 2, 3, 4, 5, 6. So he has made total 6 observations, including the 0 minute, right? And the temperatures are 22, 30, 38, 46, 54, and 62, right? These are the values of temperature that he has noted for his table, okay? Now using the pencil, draw these, right? Now he has drawn some of these, right? So the second point, I'm just going to take a thinner pencil, right? I'm just going to reduce this because these crosses need to be very well accurate, right? So I'm just going to put one cross here, right? For this, it was at I guess the value was 46, right? After 38 and 46, right? So for 2, it's going to be 38, which is going to be somewhere here, right? Your crosses need to be very well formed, right? And then we have 46 and 54, right? So it would be 46, that would be somewhere here, and then 54 is going to be somewhere here, and then we're finally going to have 62 at the very end of the graph paper, right? Now I'm just gonna the better practice is to highlight these points like this, right? before you draw the line so that they're easily visible, that these are the points that you are taking into account, right? And then you can draw a straight line using a scale. Unfortunately, you can do so on my tablet, so I'm just gonna rough sketch, right? Your line should go through as many points as possible, right? That is what you call as a line that fits best to your data, right? Write a sentence about the graph, that what the graph shows, right? The graph is showing that the as the time. Now over here you need to put in your x's as well, right? The time is in minutes, and here we have temperature in degree Celsius, right? So these need to be written, right, as per the requirement of the question, right? First label the x's with units, right? So you need to label the x's. If the graph is without x's, then it is never checked. Even in the assessment, if you do so, I'm not going to check that, right? Okay. Now, Zara, a student from Marcus' class, her plotted graph is this, right? She also did the this test, but she's doing it for a longer time, right? And then she's noting these points, right? She's marked these gray points. One of the points of the graph does not fit the pattern, and this is this one, right? Which is a little low. As you can see, if a smooth curve is drawn, this green one, this point stands out, right? It's not, understandable why it is out, right? So suggest what, draw a circle around it. So we've done that. Suggest what Zara should do about this result, right? Either she can exclude it from her curve the way I've done it, right? That's one thing. Or you can repeat the experiment to get this wrong value out, right? You probably, if you do this right, then you are probably going to get the right value on the line, right? Just like other values, right? So you can either repeat the experiment or just exclude this one point out of the data, right? Okay, then about the best fit, right? We have already done that. As you can see, the green line I drew, right? So the best fit is already there, right? Okay, describe what the graph shows, right? If you look at the graph, right, initially the temperature is going very quickly. If you see the sharpness of the graph is there, but as it is reaching closer to 100, it is becoming less sharp, right? And finally becomes nearly straight. So this shows that it is reaching near the boiling point, right? So you just need to express the trend, right? The temperature increased quickly first, and then near 100 degrees Celsius started to increase slowly, right? Okay, what happens to the temperature of the liquid as it is heated, right? As the water absorbs energy from burner, the particles become more energized, hence temperature increases, right? They start to move more vigorously, right? Okay, Zara measured the volume of the liquid at the start and end of the uh, at the start and at the end, right? So in that case, what do you think? Do you think that the volume of the liquid at the start and the end should be? Uh, what do you think the volume of the would be? This, right? Sorry, I've written no. It should be written less than before, right? Less than before, right? Sorry, my bad, right? Again, no, that means it's not gonna be the same, right? Do you think the volume would be the same as the beginning? No, it would not be the same. It would be less than before, right? So I think the word no needs to be there, right? Okay, yeah. So because what is the reason for your answer? Because high energy particles would leave the surface, hence volume of the remaining water will be less, right? That's the reasoning that you're going to have over here, right? Explaining the change of state, right? In this exercise, we will explain what happens when a liquid or a solid change state. Diagram A shows the particles in a liquid. Complete the sentences. If the particles in diagram A lose energy, the liquid will change state and become a solid, right? When these particles are loosely attached, they will become very firmly attached. So you can draw this like this, right? The particles, I told you, in solid the particles are very well arranged compared to liquids, right? So this is what you can do, and you can represent that these are vibrating, right? With the double arrow I told you about, right? You can just write that these are vibrating, that's it, and they're fixed. Okay, and in the gas, the particles, you can just make them very far away from one another, right? Which is the next part of the question, right? If they gain enough energy, and just draw these single arrows representing that they're in random motion, right? They're moving in their own directions. So this is how you can depict them, right? Just to display what a gas is supposed to look like. Okay. Now, if the particle has gained enough energy, liquid changes into a gas, right? From here, it will turn into gas. If you cool it, it will turn into a solid, right? We have done all of this in class. I'm just quickly going through the options so that if anyone who's not done this should be able to do this, right? Draw a circle around. Now, remember, whatever the statement the question is following, please follow that statement. Do not try to do this. I'll come to another point where true and false was supposed to be written and the kids are writing T and F. Please understand that this is not acceptable by the papers, right? You're right, but when the question is distinctly stating write true or false with them, you have to write the full word. Until unless the question states that you can use T or F to represent true false, then use this idea, right? Otherwise follow the directions of the question, right? Do not try to solve this. Over here the question states circle, and I see people kids who are highlighting or putting ticks, so please circle this, right? For a solid to melt, the particles must gain energy, right? They will gain energy, then they'll loosen up. The particles vibrate more, right? This is a complete paragraph, right? The particles have enough energy to escape the strong forces holding them together. In solids there are strong forces, in liquids there are weak forces, and in gases there are no forces, right? We have discussed this in class. The particles can now move away from one another. No, they can move past each other because it's turning into liquid. The solid has changed into a liquid, right? Now for question number 6, right? Each of the following word in the spaces given below. So from solid to liquid it is melting, from liquid to gas it is boiling, from gas to liquid it is condensation, from liquid to solid it is freezing. Remember, please do not use the word evaporation over here. Evaporation you guys have not studied. It's a different phenomenon than this boiling that we do, right? Boiling is due to heating. Evaporation is a natural process, right? That happens without external heating, right? You don't need to turn on the burner to evaporate something. It would evaporate on its own, right? Okay, the particle theory about the state of change. Okay, this exercise will help you understand and remember the particle theory. Remember that explaining something means that you have to say not only what happens but also how or why it is happening, right? Explain in terms of particle theory what happens when ice is heated and melts to form water. The particles will gain energy and they'll loosen up and they start to move about over each other, right? Move past each other, we said, right? Over each other. So they'll be able to move over each other, right? Okay, when a solid iron bar in the diagram is heated, right? This is the iron bar that is heated. It no longer fits the holder. And why is that? So use the particle theory, right? So as the particles gain energy, they loosen up, right? Once they gain energy, they need to vibrate more, right? Left and right, and for that they will need more space, right? For larger movement to be displayed, right? And that is what we call as expansion of solids, liquid or gas, or whenever you heat a material it will expand, right? Solids expand the least, liquid expand the most, and gases expand exponentially, okay, once you heat them. Okay, use the terms below to match each of the statement A to G, right? You have to match these statements. A state of matter where the particles do not touch each other, that would be a gas. When a gas is cooled to form a liquid, it is called condensation, right? Particles in solid, liquid, and gases do this. All of them move, right? They have different types of motion, but movement is there. So the word move is also there, right? Solid changing to a liquid, that is called melting. When a liquid changes into a gas, that is when you call it boiling or boil, right? It's boiling. The particles in the liquid, gases can do this, right? Both of them can move, right? The word vibrate is there, but that is only for solids. I couldn't find anything more appropriate that could fit over here, right? Because the word compressed is only used for gases. Evaporation would be used only for liquids, right? Vibrate, as I said, would be used for solids, right? So none of this fits over here, so I'm just use the word move. The state of matter that can be compressed, and that would be a gas, right? Some of these words were not used. For example, solid was not used, evaporation was not used, right? The word heat is not used over here. Compressed is not used over here, right? And I think the freeze is not used, right? These words have not been used. Rest were used, and two of them were repeated. Okay. Now explaining the changes of state of matter. Now you can go through these answers, right? They're very simple. Right? This exercise gives you the practice in using particle theory to explain changes matter. Use the correct scientific vocabulary. I'm just going to take the highlighter, right? Use the particle theory to explain what happens when a solid is heated, right, and changes into a liquid. So this is what you have to explain. So they gain energy, they move past each other, and they break free from the strong forces keeping the solid together, right? And hence it converts into a liquid. Now use the particle theory. What happens when a gas reaches a cold surface and changes into a liquid? This is what we call as condensation, right? So the particle lose energy and become less mobile. They start to stick together loosely and they convert into a liquid, right? As I said, these are just hints, or you can say pointers to make you understand what you need to write over here. But the answers can be in whatever form you want to write them, right? As I said, as long as this logic is explained, right? This is the requirement of the question. Use particle theory to explain what happens when a liquid is heated and it changes into a gas. Particles gain energy and start to move past move past violently, and hence they break free from the weak forces of the liquid and turn into a gas, right? So it is changing into a gas from a liquid, right? Question number 4. Look at your answers and think about the scientific words you have used. Are there any more that you should include, right? For you people, it's going to be different for each one of you, right? So that's why I've left this question empty. Now, for the water cycle, now if you remember, I told you guys that water cycle is something that you have been studying, in GK as well, in general science, in general knowledge, right? You guys have known this in early sciences as well, right? So I did not go through this much in detail, right? These are just the missing letters that were there. So you can use these or the ones I gave in the class. Both works. It doesn't matter, right? So you can just pick out these missing letters which are not printed on the book and mark on your book and accordingly name the processes, right? Now this I've left empty as a whole. Reason being, all of this has been covered already at the back, right? In the previous, like explaining the changes of state. Now explain why it rains. You can explain this in your own word. As I said, water cycle is nothing new for you people, so I'm gonna let you guys write your own answers, right? In that manner, right? So I'm just gonna leave it open. Explain what is meant by precipitation, right? Now, and this is a new term for you, so that's why I'm gonna do this one, right? So what forms can precipitate take, right? What conditions are needed for these different forms to for the precipitation to occur? So what is precipitation? It is basically when gas particles come together and they get condensed and they start forming these smaller droplets, right, of water. This is what you call as precipitation, right? So the clouds start to precipitate. The water vapors in the clouds, they this you know due to the lower temperature, they start joining together. But this is not a surface where they can collect together, right? It is not. It's a cloud, right? So they cannot get collected in one place. So they are like these small droplets which are floating in the air, right? So what conditions are required? One would be low temperature, right? And let's say for the conditions, if we go for like explain what is meant by precipitation, it is condensation of water in sky, right? That is what we call as, or clouds, you can say, right? Okay. And what really happens, what conditions are needed? That would be low temperature for sure, right? Because if there's not enough low temperature, then these particles will not lose enough energy, and they would still stay as gas particles, right? Or steam or clouds, right? Okay. Atoms of the elements in the periodic table. We've done this in quite the succession in the classroom as well as in the online class. So I'm just gonna skim through the solution of mine, right? If anyone had any mistakes, they can make corrections from this, right? So these were very easy to go through, right? We have done this in class as well as in the online class, so I don't think there's anything left out of these exercises. I'm just gonna float them over so that you can pause the video and check. And this is what I was talking about, that when the question says write true or false, please use those words. Do not go for T or F. This will not be accepted, right? If the question says circle, then circle. If the question says tick, right? Another mistake in the workbook that the students were doing, that the question says tick only the correct options. So you're ticking, and the ones that are wrong, you're just putting crosses. This is not to be done again. If the question is stating just the tick, then you have to tick as only, okay? Leave the incorrect option empty, right? That is how it is supposed to be done, right? You're not supposed to put crosses on there, right? That cross means that you are accepting that fact, right? That, in other words, if you fill this box with a tick or a cross or even with a smiley, it doesn't matter. This is considered as option taken, right? Option chosen. So if you choose an option and that is not to be chosen, then it will result in loss of marks, right? So please consider that only take is to be used when the question is stating it, right? So you can just compare your notes, right, your workbook with the solution that I've done, right? In case if you have any queries, you can just leave a comment. But I think these are very straightforward questions and straightforward answers. You just need to have a look at the priority table, okay, which is there in your book. So refer the book along with this workbook for preparation. All right. I'm just gonna move to the next page as well, right? So you can see what has been done. This was, again, as I said, this is covered in the online class. The video lesson is there if you want to go to a better understanding of what was done and why these answers are written. So you can go through that video recording as well, right? Lesson recording, and see that what we did on Tuesday during our online session, right? So these questions were solved there. I'm just gonna keep moving down, right? Some of these I could not write using the normal method, so I'm just gonna use this Na2CO3, CaCl2, right? Then CaCO3. Remember, the number of atoms come to the bottom, O2, and then K2C CO3, right? CO3 is there, right? The O was supposed to be bigger here, right? Okay, then again, these we have discussed in the class, so you can pause the video and check the answers, right? I'm just gonna move forward to the last one, right? And this is where the problem was, right? Again, another problem, that tick all the correct statements. Please keep in mind just the correct ones. Now they're doing a reaction, right? We have done this in lab, so I'm just gonna give the answers for this, right? If you remember, I took you guys to the lab and explained this whole experiment so that you guys could understand what was really happening in this exercise, right? So yes, over here, right? Over here, that is magnetic. That is gonna be true, right? You see, the one that is wrong, I'm just leaving it empty, right? I do not need to put a cross in there, right, at all. Not to be done, right? Not to be done. At the end of something so attracted to magnet? No. At the end of Sophie experiment, the test tube contains a compound? Yes, it does. Right? At the end, Marcus experiment contains a compound? No. At the end of the beaker, looks like this, right? Yes, this is how it's going to look like. Iron and sulfur are sitting separate. They're mixed up, but they're separate particles. Sophie's experiment, that is also true. Compound have the same properties as the element they're formed with? No, unfortunately. That's incorrect, right? And then we did these, right? Which boxes contain gases? That would be A, B, and C, right? A, C, and D, right? Which boxes contain because the particles are separate far away from one another, right? Which boxes contain mixtures? Mixtures are when two or more substances are mixed together. So that would be E, that would be C, that would be D, and that could be F, right? But we'll not take F because over here we see that it could be a molecule, right? So we're sure about C, D, and E for sure, right? F, it's a bit more confusing. Which box contains a liquid? And that would be F, right? And that's for sure. And if you look, since the liquid particles are also there, as I said, we are not sure whether this is one black or two white. This is not much clear, so we can say that this is a solution, right? Or it could be a mix of two liquids, right? But I'm just taking this as a mix of two liquid. Let's say this is liquid A, and then the white ones are liquid B. In that case, it is going to be listed over here in question number 3. Okay, which boxes contain a mixture of elements, right? And that would be mixture of elements, that would be D and E, because there are two pure substances. There's these small light gray, dark gray, and over here also light gray particles and dark gray particles, which are separate from one another, but this mixed around, right? So that would be D and E. Which box contain a mixture of compounds? Compounds are when different types of chemicals are mixed up. That would be this. and this, right? These are different, which are mixed up together. These are compounds, right? And that's about it, right? Because rest are not compounds. So that would be sorry, that was option C, right? Okay, that would be C. Give an example of the two elements and example of the two same element. Give an example of a compound made from two elements and an example of mixture of the two elements, right? The one that done in the experiment just now, right, would be iron sulfide, right? That would be the compound, and it's made out of iron and sulfur, right? And it could be a mix of iron and sulfur powder, right? The way we did in lab, right? Okay, explain the difference between a compound made of two elements and a mixture of those two, right? Mixture would have individual properties, right? And compound would have new properties, right? As I said, I'm just giving you hints. You can just compare your notes. Your answer must tackle to these, right? Okay, explain how the properties of a compound are different from the properties of two elements because they combine together, so their chemical behavior changes, right? So chemical behavior changes after reactions, right? Whenever a reaction takes place, the chemical behavior changes, right? Explain how the properties of mixture are different from those of a compound. The mixture will have individual properties of the elements while the compound will not, right? So that's it for your unit 3 solution. So you can pause the video and you know, go through any topic that was not clear to you that was not clear to you before, and get the answers for it. All right, bye bye, take care.